Okay, so it was brought to my attention that in the full video, the sound cut off for this slide only. So I'm just making another video so that way you have the instructions for it. All right, so when we name with polyatomic ions, right, we want to remember that they have special names, but this doesn't change the rule for how we name ionic compounds. We're still going to say the cation name, and then the anion name. All right, so let's take these, first we're going to take these names and come up with what their formula unit is. All right, so first we see copper 2. Remember that 2 tells us the charge, so we have Cu 2+. And then sulfate, remember the 8 is that indicator that it's the polyatomic. And so sulfate is SO4 2-, so we can see that it's 2- and 2+, so they're going to form 1-to-1, so we'll have CuSO4 for that one. Right? Ammonium, that's it doesn't look like a metal, right? It seems like something different, so that'd be your clue that's a polyatomic, and that's NH4+. All right, and then hydroxide, hydro for hydrogen, ox for oxygen, so that is your indicator that it's OH-. Again, we see they're 1-to-1, so it's NH4OH. When you have polyatomics, you don't want to condense them down. You want to keep them in their form as a unit. All right, so these are already in their formula unit, so we don't need to do that, but we need to name them. All right, so we look at Li, and we know that is lithium. And then NO3, when you see a nonmetal attached to oxygen, or multiple oxygens, that's a good indicator that it's a polyatomic. And NO3 is nitrate. So that's lithium nitrate. Right? Here we see Na, and that is sodium. And then we have CO3, so again we have a nonmetal attached to multiple oxygens, so it's a good indicator that it is a polyatomic, and that one is carbonate. So what we have here is sodium carbonate, right? So that's just how you name them. All right, so hopefully that fills in the blanks on that video there.